Bismillahirrahmanirrahim. Today, inshallah, I'd like to talk about some of exterior angles of polygons. Previously, we talked about the sum of interior angles of polygons, and I gave this particular pentagon as an example. The interior angles, for example, here would be like if I were to label these 1, 2, 3, 4, 5. So the sum of the interior angles of a polygon would be the sum of all of these particular angles. Measure of angle 1 plus angle 2 plus angle 3 plus angle 4 and 5. And we had devised a couple of formulas for calculating these out. If you can remember, we can divide this polygon into constituent triangles, so to speak, and the number of triangles you can divide a polygon would always be less than 2 less than the number of sides. So this is a pentagon, so you would have to take away 2, and then you can make 3 triangles out of this, and then each triangle is 180 degrees. And this is how you would find the sum of the all of the interior angles of a polygon. So that would be like 540. That would be the sum of all the interior angles. Okay. Alternatively, I suggested you can imagine like a little point in the middle of the pentagon, and you can draw out of a constituent triangles like this. And in this case, you'd make 5 triangles if it was a pentagon, 6 triangles if it was a hexagon. Then you would just take the number of triangles equals the number of sides. So it'd be 5, and then you would multiply that by 180. But then you would have to subtract these central angles over here, all of these, and they add up to 360 degrees like this. So either way, you would come up with 540 degrees like that, and that would be the sum of all of the interior angles of this pentagon. So that's what we did last time, and today, however, we like to do the sum of the exterior angles. That is, if I were to draw out all the exterior angles here, let me take this particular pentagon, and if you remember, every interior angle has a exterior angle associated with it. So if I were to have, let's start over here, extend this particular side over here like this, I would be able to generate the exterior angle. So you can extend this side, and then you would have this exterior angle, correct? And then you can extend this side, and then you would also generate this particular exterior angle. And in a similar way, you can generate all the exterior angles that go along with every particular interior angle. So here I would draw out these exterior angles. Now these are all different, so we have to that are not necessarily the same, and so we can go like this or something like that to suggest that they're all different. Anyway, so also of note, you can in this case we extended this particular side to generate this particular exterior angle. You could also generate extend this side to generate this exterior angle, but these two are the same, and there's only, when we talk about exterior angle, we talk about one of these, so you don't have to get both of them because they're identical, they're congruent because they're vertical angles. So to be systematically, either you go clockwise or you counterclockwise to generate all the exterior angles that are associated with each particular interior angle. So our goal today, in fact, is to find the sum of all the exterior angles of a particular polygon. So let's say, in this case, let's just label these. So instead of let's give these numbers. So let's give this one, since we have 5 here, so it goes 6, 7, 8, 9, and 10. So what's the sum of all of those angles? Well, it's interesting, and that's what we shall try to develop today. To get it started, consider the following. Okay, let me get a little bit, make more space over here. Consider the following example. To demonstrate using a more simpler example, I've drawn here an equilateral triangle, a rectangle, and a regular pentagon. So this is an equilateral triangle, meaning that all the interior angles are going to be 60 degrees because all the sides are the same. So 60, 60, and 60 degrees like this, okay? So this is a equilateral triangle. Now, if I were to draw the exterior angles here for this triangle, let's go like this, extend this side, and let's extend this side and extend this side, then I could easily find out the measure of the exterior angles, can't I? Because it's 60, and this is going to be supplementary to that. That's going to be 120 degrees. And here again, 120 degrees. And here again, 120 degrees like this. That's easy enough. So, and then I can add these up. 120, 240, and then 120 again is 360. The sum of the exterior angles here is going to be 360 degrees. Okay, that was easy enough. Now here's a rectangle. Okay, so all the interior angles here for a rectangle. If I could have drawn a square too, I guess, but all the interior angle here are going to be 90 degrees, right? Okay, so fair enough. Then I'm going to draw the exterior angles. So I'm going to extend this way. This time I'm going to counterclockwise. So I'm going to draw all the exterior angles, one at each vertex, like that. And then I'm going to have these angles over here would be the exterior angles, right? Well, that's easy enough because that's 90. So this is going to be 90 degrees. So let me use the same purple. So here's 90 degrees because supplementary. That's 90 degrees. That's 90 degrees. That's 90 degrees. So here we go. I got 490 degrees. Well, if I add all up and I get that's 90, 180, and then so if I add all these up, I get, wow, that's like 360 degrees again. That's fascinating. Well, the sum of interior angles here was 180 degrees, and here it was 360 degrees. But the sum of exterior angles for both of these is actually the same, 360 degrees. That's fascinating. Well, let's see what happens if you go to pentagon. Now, this is again a regular pentagon, which means that all the sides are congruent, like this, and all the interior angles are congruent. So that's equal. These are all going to be congruent, like this. Okay, fine. Well, what are the interior angle measures then? Okay, well, this is a pentagon. We can find it's just like over here. You can find the sum of all the interior angles. We calculate that out to be 540 degrees, right? And because you can use the formula n minus 2 times 180 degrees, or you can say it is you can divide this into 5, so n times 180 degrees, but then you have to subtract the 360 degrees. Either way, you get sum of all the interior angles, and you get that to be 540, and you divide that up into 5, so 540 here in this case would be 540 divided by 5 angles. That ends up being 108 degrees. Okay, so here we figured out that this is going to be 108 degrees, this angle. That's 540 divided by 5. Each of them is going to be 108 degrees. 108, sorry, it's 108 degrees. If I did that correctly, 108 degrees, 108 degrees. So we figured out for this particular regular pentagon, meaning all the sides are congruent and all the interior angles are therefore all the same, congruent, right? So I get 540 divided by 5, and I get 108 degrees. Now I'm going to draw out the exterior angles. Let's go counterclockwise again, like this. So draw out each exterior angle at each particular vertex here, and they're going to be supplementary, right? Obviously, they're going to be supplementary. So 180 degrees. So this angle here is going to be 180 minus 180 degrees, and that ends up being 72 degrees. And since it's all congruent, all of these are going to be 72 degrees. 72 degrees. 72 degrees. 72 degrees. Well, that's interesting. So by way of example, now if you add all of these up, so you get 72 plus 72 plus 72 plus 70, the sum of them is going to be basically 5 times 72 degrees, like this, and lo and behold, that comes up to be again 360 degrees. That's fascinating. Whether you have a triangle, a quadrilateral, a pentagon, the sum of all exterior angles is not changing. It's always, at least in these three examples, it seems to be 360 degrees. So is it possible that the sum of exterior angles is always 360 degrees? And indeed, it ends up being so. Can we prove it? And that's what we shall try to do next. Okay, so I've drawn these two pentagons here, the same ones, and here I'm going to have these angles. I'll just label some of these: angle 1, angle 2, angle 3, and 4, and 5. We've already determined that the sum of all of the interior angles was the formula. It's going to be n minus 2 times 180 degrees, right? Because that's the number of triangles you can make, and times 180 degrees. So angle 1 plus 2 plus 3 plus 4 plus 5 is going to be 180 degrees. So we figured this out. So the sum of the interior angles of any particular polygon is going to be n minus 2 times 180 degrees, and that will apply to this pentagon and any other polygon. Now observe then that if this was the interior angle here, then the exterior angle is a supplementary angle like this, and this whole thing because this is a straight line, that's 80 degrees. So this whole thing is 180 degrees, correct? And the interior angle is part of 180 degrees. So if I were to draw another interior angle here, and the whole thing is going to be 180 degrees, and the exterior angle is going to be over here, and the interior angle again is going to be part of the whole thing. So if I could say for every vertex this is 180 degrees total. So the interior angle and the exterior angle add up to give 180 degrees. So for every vertex, the interior angle plus the exterior angles, so the interior angle plus the exterior angles, if you add them all up, okay, at every vertex, that will give you 180 degrees, won't they? Because it's, of course, it's a straight line. So for every vertex, they all add up to 180 degrees. Well, for any polygon, how many of these would you have? For the pentagon, you would have 5 of these. You would have 1, like 2, and 3, and 4, and 5s, right? 5 pairs. So you would have 5 pairs of interior and exterior angles, correct? So for any particular polygon, you would have that number of pairs of interior and exterior angles, and they both add up to 180 degrees. Well, if we find the whole sum of this and subtract from it all the interior angles, okay, if you subtract from it all the interior angles, and so like this, and then you can get the exterior angles, can't you? So for example, for a pentagon, you would have 5 of these pairs, correct? You would have 5 of them. So you would have 5 times 180 degrees. So if you find the sum of interior and exterior angles together, and then from that sum, if you subtract all the interior angles, you get the sum of the exterior angles, right? I hope you follow. Because first we find the sum of interior and exterior angles together, and that's easy because that's going to be however many vertices there are, and 180 times the number of those vertices. So if you can find the sum of both interior and exterior angles for the whole polygon, then if you subtract the sum of the interior angles, then you get the sum of the exterior angles. All right, so here you go. So the sum of exterior angles, now that's going to be equal to, okay, however many numbers of vertices you have, okay, and however many number of vertices you have times the number of interior plus exterior angles. All right, and from there you have to subtract the sum of the interior angles. Then you subtract the sum of interior angles. Okay, let me put it this way again. So the sum of all the exterior angles is going to be the interior plus exterior, and however many you have, that's going to be, for a pentagon, that's going to be 5 times interior plus exterior, and from this I have to subtract all the interior angles, and I get the exterior angles. Okay, so I've just rewritten this, try to do it a little bit more neat. So the sum of all the exterior angles is going to be n times interior plus exterior. That's easy, that's 180 degrees. So all of these, okay, interior plus exterior, that's always going to be 180 degrees because they're supplementary. All right, and taken away, subtract that from the sum of all the interior angles, which is n minus 2 times like 180 degrees. I've written that. So they all, n times 180 will give you the sum of both interior and exteriors, and you take away all of the interiors, you get that. Well, then you do a little bit of algebra here. That's easy enough to do. So this is 180n, and you distribute this over here. All right, you can distribute that over there. You have to be careful with this negative sign here, okay? So let me just distribute it like this. So 180n, sorry, 180n minus 2 times 180 is 360 degrees, like that. You have to make sure you distribute this negative sign here, okay? So when you distribute the negative sign, as I said, you have to be very careful. These you get 180n minus 180n, and negative times negative will give you positive, right? So if you distribute that, positive 360 degrees, like this. Well, that's easy. Now you can look at this. These two cancel, and the sum of the exterior angles is 360 degrees. Ta-da! So we have proven over here that the sum of exterior angles is always going to be 360 degrees. The way we did that is we said for every vertex, these two pairs, the best buddies, interior and exterior angles, they add up to 180 degrees. Okay, since they add up to 180 degrees, and there are going to be n of those, n times 180 degrees, right? That's the sum of both interior and exterior. And so from that, if you subtract away the sum of all the interiors, then you get the sum of exterior angles. And the sum of exterior angles always would turn up to be 360 degrees. So that's our proof that the sum of exterior angles is always 360 degrees. Okay, so to finish off, we have our theorems. The sum of exterior angles of a polygon theorem, the sum of exterior angles of a convex polygon, again, is 360 degrees. In our particular example of these 1, 2, 3, 4, 5, the sum of all of these exterior angles is going to be 360 degrees. And here's an example to finish off our lesson today. And the question is, find the value of x over here in this particular diagram. This happens to be a pentagon also, but it doesn't really matter. We're given all the exterior angle measures in algebraic expressions, and we are supposed to solve basically for x. And that's easy enough because these are all exterior angles, and we all know that they all add up to 360 degrees. So we just write this, we add them up. So 2x minus 5 plus 3x plus 10 plus 6x minus 5 plus 2x plus 5x, they all must add up to 360 degrees because the sum of all the exterior angles at all times is 360 degrees. Now you can simplify this. That's all adding up the like terms. So here are the like terms: 2, 5, 11, 12, 13, and 18. So that gives you 18x, negative 5, then that's 5, and that's 0. So all of these numbers add up to 0. It's pretty convenient, and that's 360 degrees. And then you divide both sides by 18. So divide this, that's 18x basically equals 360 degrees. Divide both sides by 18, so half is right. So that's it, 20. That's the answer. So the solution is x is equal to 20. In this question, they did not ask us to find the measure of each angle. They asked us to solve for x, and they were kind enough to leave it there. And that's how you do it. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.